So today we'll be doing configuring of VLAN and trunks. So before we do configuring of VLAN and trunks, so we will first do the explanation of what is a VLAN, what you understand by a VLAN. So let us say for a company, he has an HR department, an IT department, a payroll department. They have different types of users. They need different types of access. So some companies, what they do, they have a switch for HR departments to create the HR LAN. IT LAN will have another switch and another switch for payroll LAN. But when a switch has several LANs in only one switch, this means this switch supports VLAN. So VLAN is being used. The concept of VLAN is here. So VLAN, it means virtual LANs. So in one switch, we can have several LANs, but to have several LANs in one switch, we have to configure VLANs. It's as simple as that. Now, state the features of VLAN. No, before we do this, let's see here. Here we have a diagram. We have the IT, HR, and then sales department. For the IT, you will notice we have three PCs here, three PCs in VLAN, three PCs in sales. They are all connected on a different switch. But in VLAN, several VLANs can get access. If all VLAN 10 will get access on the different floors, all the VLAN 3 will get access to each other. Now, VLAN, if I have VLAN 10, we have VLAN 20, we have VLAN 30. All VLAN 10 will speak to VLAN 10. All VLAN 20 will speak to VLAN 20. All VLAN 30 will speak to VLAN 30. Unless we want them to do otherwise, we can reserve each VLAN to talk to each other, not to talk to each other. Now, virtual LANs provide segmentation and organizational flexibility in a switch network. So, virtual LANs, what they do, it divides the devices into several VLANs. This is what segmentation means. A group of devices within a VLAN communicate as if each device was attached to the same cable. They're based on logical connection. The administrator would segment networks based on factors such as function, team, or application, without regard to the physical location of the users or devices. Wherever they are, if VLAN 10 has to talk with VLAN 10, wherever they are in the network, so they get access. Devices within a VLAN act as if they are in their own independent network because they share a common infrastructure. Now, 5 benefits of VLAN: smaller broadcast domain, improved security, improve IT efficiency, reduced cost, better performance, and then we have simpler project and application management. Now, there are 5 types of VLANs. We have default VLAN, data VLAN, native VLAN, management VLAN, voice VLAN. These are the VLANs that we are going to describe, and we have to work on these VLANs and we are going to configure these VLANs also on our Cisco switch. VLAN 1 is the default VLAN on a Cisco switch. So on all switches, by default, you will have VLAN 1. Point to be noted here, VLAN 1 cannot be renamed. It cannot be deleted. You could be creating several VLANs. They could be deleted, but VLAN 1 cannot be deleted. Default VLAN can be configured. Now we can configure that VLAN 1 with an IP address. Why? Because we want the switch to be accessed remotely instead of attaching a console cable directly to the switch and come to the switch to configure the switch. We can configure the switch remotely via an email address. Sorry, via an IP address. Now, give a brief description on data VLANs. Data VLANs are VLANs configured to separate user-generated traffic. They are referred to as user VLAN. So another name for data VLAN is also user VLAN because they separate the network into groups of users or devices. A modern network would have many data VLANs depending on organizational requirements. Note that voice and network management traffic should not be permitted on data VLANs. Next, we have native VLAN. Now, a point to be noted here, with native VLAN, it's configured on trunk. When do we say it's native VLAN? It's when untagged frames are being sent. So when untagged frames are traversing the network, this means it's going to the native VLAN. It is a native VLAN. VLAN 1 by default can be a native VLAN, but we will never, it's a good practice not to consider VLAN 1 as the native VLAN because hackers would attack, for our hopping attacks, will attack our LAN easily. We can put VLAN 88, 98, any other number for security purposes that you're going to configure as native VLAN. Let's see now. Before I move forward, I want to show you something in my packet tracer. Now, here we have VLAN 10. Here we have VLAN 20. Here we have VLAN 30. VLAN 10, VLAN 20, and then VLAN 30. My PC here, 172.17.10.21 is the IP address of this PC, but the network is this because we have 3 times 255 here. So the network address will have is 3 up there. C'est 10.21. PC2 desktop IP configuration 172.17.20.22. 3 fois 255 ici. PC3 c'est 30. So different networks, VLAN 10, VLAN 20, and VLAN 30. They are from different networks. Now, here we have VLAN 10. This PC is VLAN 10. This PC2 is on VLAN 20. PC3 on VLAN 30. Here PC6 is on VLAN 30. PC5 on VLAN 20. PC4 on VLAN 10. So when it's going from this switch, when VLAN 10 has to send information to VLAN 10, it has to go through this network. Now, ici, là, we can have VLAN 10, 20, 30 that wants to go through. We can have a 4-bit tag frame with it. So here we can configure this as a trunk. We have to configure it as a trunk because it's going to carry several VLAN. It will carry VLAN 10, 20, 30, and if a native VLAN is configured, the native VLAN also will be passing through this. Now, if we configure this as VLAN 88, then we have to configure this as well, the native VLAN as 88. Else we'll have native VLAN mismatch. So it has to be same. The native VLAN number has to be same. Here we have a trunk here. Here also, trunk will be configured as trunk. Because a trunk is a conduit that carries several VLANs together to the other switch so that it can reach the destination. Okay, next we have management VLAN. A management VLAN is a data VLAN configured specifically for network managed traffic, including SSH, Telnet, HTTPS, HTTP, SNMP, etc. By default, VLAN 1 is configured as the management VLAN on a layer 2 switch. Voice VLAN. A separate VLAN is needed to support voice over IP. Voice over IP traffic requires the following: assured bandwidth to ensure voice quality, transmission priority over other types of network traffic, ability to be routed around congested areas on the network, delay of less than 150 milliseconds across the network. And to meet these requirements, the entire network has to be designed to support voice over IP. Next, state the importance of using trunks. So I already told you it's a conduit for multiple VLANs between switches and routers. Well, here we have only switch. A trunk is a point-to-point link between two network devices that carries more than one VLAN. So here it's going to carry VLAN 10, VLAN 20, and then VLAN 30 here. Here, this port FA01 has to be configured as trunk. This also has to be configured as trunk. This also has to be configured as trunk. And this also has to be configured as trunk. A VLAN trunk extends VLAN across an entire network. Cisco supports IEEE 802.1Q for coordinating trunks on fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet interfaces. So you will take note again that VLAN 10 will be able to talk with VLAN 10 in this network. VLAN 20 will be able to speak only with VLAN 20. We will not be able to speak with VLAN 10. We will not be able to speak with VLAN 30. Next. Now, how do we create VLAN? So we'll go back on our packet tracer. So we'll go back on our packet tracer. Let's configure VLAN here. Nconf. Now, we have to configure numbered VLAN. So VLAN 10, this is known as a numbered VLAN, numbered because it has identifier 10. Now I name this VLAN 10 as faculty. Here it is. VLAN 20, I give it the name of student. Right. VLAN 30, I give it the name guest. Okay. So now I want to see the VLANs I've created. I'm going to type the command show VLAN brief. So VLAN brief will display all VLANs created on this switch. And here it goes. You will take note. We have here VLAN 1. Because it is a default VLAN, all ports are attached to this VLAN. All ports are attached to VLAN 1 because it is the default VLAN. 10, 20, 30, they are the VLANs that we created. We just created. Now, we have 1002, 1003, 45. 1002 is FDDI default, 1003 token ring default, 1004 FDDI net default, etc. So 1002, 3, 4, 5, they are reserved for these purposes and they cannot be renamed or deleted, just like VLAN 1. Okay, so that's why. Now, how do we put an IP address? So we go back here. How do we put an IP address? So conf pareil, interface VLAN 10. I want to put an IP address to it. IP address 172. Allons mettre 17.10.2. Subnet mask 255.255.0. VLAN 20. I can put IP address here 20.2. interface VLAN, sorry. It's interface VLAN 20. To configure the IP address, it's interface int VLAN 20. When I put the IP address, this interface VLAN 30 ici 30.2. Good. So this I have configured the VLANs here. 10, 20, and 30 with an IP address. Okay. Next slide. Now we have normal range VLANs. We have extended range VLANs. Now let's see what are the 6 important features of normal range VLANs. They are used in all small and medium-sized business and enterprise networks. They are identified by a VLAN ID between 1 and 1005. C'est-à-dire tout VLAN ID entre 1 à 1005. They are normal range VLANs. IDs 1002 through 1005, I just showed you before. They are reserved for legacy network technologies. IDs 1 and 1002, 1005, they are automatically created and we cannot delete them, we cannot remove them. Now, we've learned before that when we have to delete our configuration, when we have to remove the configuration on our switch or router, we use erase startup-config. But on switches, when you're going to use erase startup-config, your configuration will go except VLANs. VLANs will not be deleted. Why? Because when we create VLAN, it is stored in a file called VLAN.dat. Here it is, VLAN.dat. If we want to delete the VLANs that we have created, we have to use delete. Let's do it on our packet tracer here. Okay, I've created. So how do I delete the VLANs created? We go delete VLAN.dat or delete flash column VLAN.dat. Okay, then I have to reload to see the changes. I'll reload my switch, means I'll reset my switch. Save, no. Okay, so now let's see, we'll show VLAN brief. And it's gone. We no longer have 10, 20, and 30. But these VLANs will stay because we cannot delete them. But 10, 20, 30, the ones created, student, faculty, guests, they have been deleted. You can't see it here. So I'll create it again. Do it fast. VLAN 10, name faculty, VLAN 20, name students. This time VLAN 30. Now I'm going to put it name. I put it as it is in my on my slide. Name student. VLAN 30. Name. What is the name? Guest. Now, if I have to carry next slide here, this is normal range VLANs. When configured, VLAN trunking protocol helps synchronize the VLAN database between switches. Next, we do extended range VLANs. They are used by service providers to service multiple customers and by global enterprises large enough to need extended range VLAN IDs. They are identified by a VLAN ID between 1006 and 4094. Configurations are saved by default in the running configuration. They support fewer VLAN features than normal range VLANs. They require VTP transparent mode configuration to support extended range VLANs. So when we have VLANs, we can create up to 4094. But if it is from 1006, if your VLAN ID is 1006, 1008, 2000, so then it is known as an extended range VLAN. Next. Now we have to assign ports to our VLAN. FA011 avec VLAN 10. So let's go back to our packet tracer here. So how does the switch know that here we have to use VLAN 10? So we have to do port addressing. We are going to assign the port to the VLAN it's expected to work with. How do we do it? We'll say interface. Here I think it's interface FA011. FA011. Then I put switch port mode access. Why access? These PCs here, they're trying to access the network. So in the hierarchical network model, they form part, all devices that will form part the access layer. Access layer, why? Because they're accessing the network. They are devices, they are end devices used to access the network. So that's why switch port mode access, switch port access VLAN 10, because VLAN 10 will be working with them. Next interface FA018 VLAN 18, switch port mode access VLAN 20. Can do it directly as well. Interface FA /6, switch port mode access, switch port access VLAN 30. And here I created these three. VLAN 10 is going to be on PC1, PC2, PC3. Now, VLAN 10 here has to talk to VLAN 10. VLAN 20 has to talk to VLAN 20. VLAN 30 has to talk with VLAN 30. So all this here, the trunk, this is trunk. It has to carry all three VLANs. It has to carry with tag frames. Let's say it carries with tag frames. So it comes to the switches here, it comes here. Now access ports do not accept tagged frames. So what the switch will know? The switch will look at the tag frame, will see, okay, this is for VLAN 10, the PC1 on VLAN 10. So it removes the tag, it just throws away the tag and sends the frame to that PC. If a frame being sent does not have a tag frame, so then this means it is addressing the native VLAN, devices that are form part of the native VLAN for untagged frames. So how do we configure trunk? Here it's FA01, FA01. We have to configure the same VLAN ID as native VLAN or, for the trunk. Same VLAN ID should be here. If I put 99 here, it has to be 99 here. Else there will be mismatch. Now, interface FA01. So now this is a trunk. So switch port mode trunk. Okay. switch port trunk native VLAN 99, I'll put it 99. Then I'm going to tell the switch which VLANs will be allowed to pass the trunk. Switch port trunk allowed VLAN 10, 20, 30, 99. Because the native VLAN has not been set 99 yet here. That's why I get this native VLAN mismatch. Once it's configured, we won't have this mismatch. Good, so let's do the same thing here. Copy, run, start to save a configuration. Good. CLI here, and conf. So I want to configure FA01 as trunk. Switch port mode trunk. Switch port trunk native VLAN 99. Pareil, switch port trunk allowed. What are going to be allowed on this? 10, 20, 30 and 99. Only these VLANs, for security purposes again, will be able to go through this switch. Good, so this is how we configure trunks. So here we have defined how we configure the voice VLAN. Okay, next we have here. Ça, j'ai déjà expliqué. How we remove VLAN, I've shown you. You can write either delete VLAN.dot or delete flash column VLAN.dot. And trunk, I've just showed you how to do it. And that's it for today's session. Thank you.